Friends, welcome to the module number 2, that is failure of materials. Okay, we are going to discuss about two content in this module, that is creep and stages of creep. First of all, let us understand what is meant by creep. Suppose if you take any mechanical strength of metals, it decreases and increasing the temperature, and the properties becomes much more and more depend upon the time. Okay, for example, if you take any part of furnace, okay, or turbine blades, if you take so steam generator, like that, so all are subjected to the under heavy stress at elevated temperatures. Okay, so the deformation of components under such circumstances is termed as creep. Okay, this creep can be defined as a time dependent and permanent deformation of material when it is subject to a constant load at a high temperatures and greater than around zero point 0.4 temperature of mean temperature. Okay, let us discuss about in detail about the creep and stages. Okay, and this creep, as I told, creep is occurs at temperature at greater than about 0.4 tm, where tm is nothing but the absolute melting temperatures. Okay, the creep leads to a fracture is normally what happen. It is undesirable phenomena, and it is often a limiting factors. Okay, in lifetime apart. Okay, suppose the creep have a high that is leads to a fracture at statistic stresses, okay, much smaller than those who will break this specimen. Okay, when the load is quickly, okay, when the load is quickly, so hence the load of understanding the behavior of the material at a high temperature is beneficial for in elevating the failure in these types of materials. Okay, we can found okay example for soft materials, say like lead. Okay, the creep effects become a significant at low temperatures, and however it of high temperature strength materials, the creep effects becomes significant in high temperatures, and all are negligible in at ordinary at room temperatures. So for example, if you say for a high melting point of metal like tungsten or other materials, so the temperature above 1500 degrees centigrade so would be needed to produce a creep. Okay, for such a creep it is under the stresses. Okay, and the polymers or the creep is often quite significant at room temperatures, and even more negligible at high temperatures. So this is all about the creep, and let us will discuss what are the different stages of creep. Okay, so along this graph we can see the strain along with the time. Okay, this creep curve we have shown here. We can plot on percentage of elongation, or what we call the strain against time increment until it test the specimen takes place. Okay, the three stages of creep can be identified in the creep curve, and the same are discussed like this. Okay, we will discuss now. First stage, what we call as at the first bottom, we can see here. So that is primary creep, what we call as primary creep and secondary creep and tertiary creep. Later it becomes fracture. So first we will discuss about the primary creep. Okay, so initially what happened, the stage of creep, we call it as a primary or a transient creep. It is a period of decreasing the creep rate. Okay, that is what we, that is dE by dt, that is the strain along with the time. So during this period deformation takes place, and resistance to the creep increases until reaches the stage 2. Okay, in other words, what you can say, for the secondary creep progressively decreases because of that metal deforms, and it undergoes the strain hardening and offers more and more resistance to further elongation. The effect of the creep we can see in the figure. Okay, and this will be required of this stage. Okay, so for the next secondary creep, what happened, the maximum the secondary creep occurs when which is the creep is roughly constant, because the d by dt is a minimum of creep rate at this stage. So in this region, the rate of strain hardening is balanced at the rate of recovery or recrystallization of leading to minimum constant creep rate. So hence what we call the stage 2 is referred as a steady state creep, means there is not much changes along with the time. Okay, so this is about the secondary creep, and finally we will move on to the tertiary creep. Okay, so in this tertiary creep, what happened, there is it is almost reaching the final stage of the creep. So this is what we call it as the third stage of creep, and in which where it is an accelerating the creep rate until fracture occurs. So the tertiary creep occurs when there is a reduction in cross sectional area due to the necking, or effective reduction in area of the specimen due to the internal weight of the formation. So this is about the tertiary creep, and further this necking will cause an increase in the local stress of the component, which further accelerate the strain, and eventually the material will pull apart a ductile material around the defects in solids. Okay, so this is about the so what happened, even though the material will pull apart this rectal fracture around the defect the solid material. So from this graph what we understood that the secondary creep is often the stage of creep that is our longest duration. Okay, and in this creep testing the goal is to determine the minimum creep rate in a stage 2. So once the designer knows of any material, the will knows the material will creep, and it has occurred for these deformations. Okay, so the primary goal is to avoid the failure of the component. So hence the secondary creep stage forms the important part of the creep curve. So most of the working components will be in this stage only. So even if you take for a rubber or any last material, so under creep only. Okay, so continuous deformation may be taking place. Okay, so I hope you understood this concept. Further we will discuss the most of other related to this creep we'll discuss in the next slide. Okay, so this is about the creep. So here we can see this deformation. So along with this strain and the time curve, there is start with some clearance value, that instantaneous elastic strain will be there. So after that only it will be start develop in the creep formation in the material. So that we can observe here, that is instantaneous elastic strain, that is sigma divided by E, that is stress divided by Young's modulus, that particular material. So I hope you understood this all creep and all other concept. We'll move on to the next slide. Thank you.